Part A. Use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, time t equals 1/4. For this, to get the tangent line, we need to use the derivative of W, which was given to us as 1/25 times W minus 300. So we're going to do this at t equals 0, and we also know that at t equals 0, the initial amount of solid waste is 1,400 tons. So to get the tangent line for t equals 0, I'm going to plug in for the slope. 1,400 minus 300, and this equals 44. So our tangent line equation is y equals 44, the slope that we just solved for, t, plus our initial condition, which is 1,400. Then, from there, we want to solve for when t equals 1/4. So we're going to plug in 1/4 for t. Which then gives us 1,411. And we will take this as the approximate value for t equals 1/4. Part B. Find this in terms of W. Use this to determine whether your answer in Part A is an underestimate or overestimate of the amount of solid waste that the landfill contains at time t equals 1/4. This is the second derivative of the differentiable equation. That's right. That's not right. This is the second derivative of dw over dt. And so, knowing that dw over dt equals 1/25 w minus 300, we're going to take the derivative of this, which will give us 1/25 times this equation again. So 1/25 times 1/25 times w minus 300. This is t squared w over dt squared, or 1/625 w minus 300. So for this, we're going to use the W value. W is always going to be greater than or equal to 1,400. 1,400 is our initial condition. So we want to determine if this is an estimate or overestimate. We need to find the slope by plugging in t0 and t 1/4. t0 into here is 1,400, which will give us out a number that is greater than 0. Plugging in at 1/4, our number was 1,411, which is still greater than 0. Thus, d squared w over dt squared is greater than 0 on the interval 0 less than or equal to t less than or equal to 1/4, which means that our tangent line approximation was a underestimate because our graph is doing some increasing function. Our tangent line did this. It estimated below the actual value. Find the particular solution W equals Wt to the differentiable equation dw dt equals 1/25 times the quantity of W minus 300 with initial condition W0 equals 1,400. So to start this problem, we take dw dt and we integrate it. But first we have to do separation of variables, which is shown here. Divide over W minus 300, multiply over dt, leaving you with this integral. Integrate, leaving you with this plus c on this side. And then from here, going to come up to this part and plugging in our initial conditions. T at 0 equals 1400. And then solve for c, which is the natural log of 1100. And then from there, we come over to here and we take our e, multiply it through, and we're going to be left with w minus 300 equals c e to the 1 over 25t. And because the c is here, because this value right here becomes the equivalent of e to the 1 over 25 times t, that whole quantity times e to the c, and e to the c is just the same thing as c. So w equals 300 plus c e to the 1 over 25t. And then finally plug in our natural log. W equals 300 plus 1100 e to the 1 over 25t. And the reason why the natural log gets dropped is because back here, when it was e to the c, if you were to plug in the natural log for c, you're going to e to the natural log. E to the natural log leaves you with whatever was in the natural log itself, which is 1100. Thus, that is the final answer.